Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll use the concepts of derivatives to solve this problem. So as per the problem, find the critical points for the function. Use the first derivative test to determine where the critical point is a local maximum, local minimum, or neither. Then find the x and y-intercepts and sketch the function. Now the given function is f at x equals 2x over x squared plus 9. So first we have to find the critical points, and critical points are points at which the derivative of the function is equal to 0 or undefined. So the first step here is to find the derivative of this function. Now this is a rational function, so we should use quotient rule to find its derivative. So prime of f at x. So as per the quotient rule, so we start with the derivative of the numerator. So the derivative of 2x is just 2 times the denominator x squared plus 9 minus the numerator 2x times the derivative of the denominator. So derivative of x squared is 2x as per the power rule, and the derivative of 9 is 0 because 9 is a constant, divided by the square of the denominator. Now we can simplify the expression in the numerator, so we can distribute the 2 into the parentheses, and we can distribute negative 2x in the other parentheses. So we get prime of f at x equals 2x squared plus 18 and then minus 4x squared over x squared plus 9 squared. Now for critical points, so the derivative of the function should be equal to 0 or undefined. Now this expression here will be undefined if the denominator becomes equal to 0. So we should find the x values that will make the denominator equal to 0. So we should set x squared plus 9 equal to 0 and solve for x. So we can isolate x by moving 9 to the right side of this equation. So we should subtract 9 from both sides. So the 9's on the left side will cancel each other out, and we get x squared equals negative 9. Now x squared cannot be a negative number because when you square a negative number, the result is a positive number, and when you square a positive number, the result is a positive number. That means there is no x value that will make the denominator equal to 0. So that means this expression for prime of f at x cannot become undefined. So the next step is to sub in prime of f at x as 0 and solve for x to find the x values for which the derivative is equal to 0. So we get 0 equals, so in the numerator we can combine the x squared terms. So 2x squared minus 4x squared is negative 2x squared plus 18 over x squared plus 9 squared. Now we can cross multiply the denominator. So the denominator will go away because 0 times x squared plus 9 squared is equal to 0. So we get 0 equals negative 2x squared plus 18. And now we can just move on this side. So now we can subtract, or we can add 2x squared to both sides. So the 2x squares on the right side will cancel each other out, and we'll just move to this side to save some space. So we get 2x squared equals 18, and now we can divide both sides by 2. So if we divide both sides by 2, so the 2's on the left side will cancel each other out and we get x squared equals 9. And now we can apply square root to both sides. So the square and the square root on the left side will cancel each other out and we get x equals plus minus 3. So there are two x values at which the derivative is equal to 0. Now we have to find the critical points. So these are the critical numbers. So x equals positive 3 and x equals negative 3. Now we should sub in x as positive 3 and negative 3 in the given function f at x to find the y value, and then we will know the critical points. So let's start with x as negative 3. So f at negative 3 will be equal to 2 times negative 3 over negative 3 squared plus 9. So this can be reduced to f at negative 3 equals, so in the numerator 2 times negative 3 is negative 6 over, and in the denominator negative 3 square is positive 9 and 9 plus 9 is 18. So negative 6 over 18 can be reduced to negative 1 over 3. So the first critical point is negative 3 and negative 1 over 3. Now we can find the second critical point. So we'll sub in the second critical number x as 3 in the given function. So we get f at 3 equals 2 times 3 over 3 square plus 9. So f at 3, 2 times 3 is 6 over 9 plus 9. So f at 3 is equal to 6 over 18, which can be reduced to 1 over 3. So the second critical point is 3 comma 1 over 3. So we are done with the first part of the problem, finding the critical points. Now we have to use the first derivative test to determine whether the critical point is a local maximum, local minimum, or neither. So for this, we'll have to use the number line method to find the sign of the derivative of this function on either side of the critical point. So we can start by drawing a number line. So the critical numbers we got are negative 3 and positive 3. So these two critical numbers divide the number line into 3 parts. So we'll have to use a test value from each part. So to the left side of negative 3, the test value we can use is negative 4. Between negative 3 and positive 3, we can use 0. And to the right side of 3, we can use 4. So we have to find the sign of prime of f at x for these three test values to know whether the function is increasing or decreasing in these parts of the number line, and then based on that we'll find out where the critical point represents the local maximum or local minimum. So let's start with x equals negative 4. So we'll sub in this x equals negative 4 in the prime of f at x. So prime of f at negative 4. Now we are only interested in the sign of the result, not the value itself. So prime of f at x we got was negative 2x squared plus 18 over x squared plus 9 squared. So we get negative 2 times negative 4 squared plus 18 over negative 4 squared plus 9, and then square. Now in the denominator, the result will always be positive. Now in the numerator, so it's negative 4 square, which is equal to positive 16, and 16 times 2 is negative 2 is negative 32. So we'll get negative 32 plus 18 over. Now the result in the denominator will be negative. Will always be positive, we said. And the result in the numerator will be negative, because negative 32 plus 18 will give us a negative result. So means prime of f at x equals negative 4 will be a negative value over a positive value, which will give us a negative result. So that means the prime of f at x to the left side of the critical number x equals negative 3 is negative. That means the function is decreasing to the left side of negative 3. Now we can do the test for x equals 0. So we'll sub in x as 0 in the prime of f at x. So prime of f at 0 will be equal to negative 2 times 0 square plus 18 over negative 0 square plus 9 square. Now in this expression, the numerator will be a positive number, because negative 2 times 0 square will just be 0. So we'll get positive number in the numerator and positive in the denominator. So that means the final answer for prime of f at 0 will be a positive number. That means the function is increasing to the right side of negative 3, because we got a positive result for prime of f at 0. Now we can do the test for the test value x equals 4. So prime of x at 4, so we get negative 2 times 4 square plus 18 over 4 square plus 9 square. Now in the numerator, so 4 square is 16, and 16 times negative 2 is negative 32 plus 18, and the numerator will be a positive number. Now here the denominator will be a positive number. The numerator will be negative, so we'll get negative over a positive result, which will be equal to a negative overall result. So that means the function on the right side of the critical number x equals 3 is a decreasing function. So now we can use this result to find where the critical points represent local maximum, local minimum, or neither. So let's start with the critical point at the critical number x equals negative 3. So at this critical point, so the function is decreasing on the left side and increasing on its right side. So that means there is a local minimum at the critical point negative 3, negative 1 over 3. Now we can analyze the other critical number x equals 3. Now to the left side of x equals 3, the function is increasing, and to the right side of x equals 3, the function is decreasing. So that means there is a local maximum at critical point 3, 1 over 3. So now we have answered the second part of this problem. Now in the third part, we have to find the x and y intercepts and sketch the function. So let's start with the intercepts. So for x-intercept, we'll have to sub in y as 0 in this function equation and then solve for x. So we get 0 equals 2x over x squared plus 9. So we have to solve for x. So we can cross multiply the denominator. So 0 times x squared plus 9 will be equal to 0. So 0 equals 2x. And then we can divide both sides by 2. So the 2's on the right side will get cancelled out. So we get 0 equals x. So the x-intercept is 0, 0. Now we can find the y-intercept. And for y-intercept, we should sub in x as 0 in this given function. So f at 0 equals 2 times 0 over 0 squared plus 9. So we get 0 over 9, which is equal to 0. So the y-intercept is the same point, 0, 0, which is also the origin. Now we can use all of this information to sketch this function. So we'll start by plotting the points we know. So we know the x and the y-intercept are the same, which are the origin. So we can plot that. So this point lies on the function. And then we also have the critical points, and the critical points are 3, 1 over 3. So let's assume this is 1 over 3. And let's assume this is positive 3. So this point lies on the function, and this is a local maximum, and then the local minimum is negative 3, 1 over 3. So here it's negative 3, and then negative 1 over 3. So the local minimum is at negative 3, 1 over 3. So this point. Now we can sketch the graph. So on the left side of negative 3, the function is decreasing because we got a negative sign for prime of f at x. So that means from left to right, the graph is sloping down because any tangent that's drawn to this function should have a negative slope. Now to the right side of negative 3 and up to positive 3, the function is increasing because prime of f is positive. So now we have to continue the graph to the right side of negative 3, and it should pass through the origin and continue all the way to the local maximum at x equals 3. So like this. Now to the right side of 3, the function is decreasing. So now we have to draw the curve which is sloping downwards. So it can go down like this. So this is the sketch of this given function f at x equals 2x over x squared plus 9. So these are the steps you have to keep in mind to solve a problem like this one. So it's very important to understand that we have to first find the derivative of the given function to find the critical numbers, and then we use those numbers and sub them in the given function to find the function values and use them to find the critical points. And then we use the first derivative test to find whether the critical points are local maximum or local minimum or neither, and then we find the x and y intercepts to sketch the function. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.